Hello, and welcome to the final video in this series on the second recurring worksheet. Oh, don't look at that, sorry. Where we're going over problem 4 of worksheet 2. This one's called static electricity. It's an extra problem. This one's a really tricky problem, but it's a very good one to do. If you remember on the first worksheet, there was the problem about like the bear object and everything. This is a very similar one to where we're testing your ability to keep track of like static variables, local variables, instances, and all that stuff. But this is really kind of an amped up version of that question from the first worksheet. And if you can do this, you can probably do any of them. So let's get started in doing it. The first thing I want to do, as before, in the first one I did, is I want to take a look at the actual class before we actually start running methods. So in case you don't know, or if you haven't read the problem, basically what we're going to do is we're going to run this main method here, and we're just going to, show what is printed out at any given line. That's the goal of the problem, but let's look at the overall structure of the class first. So we have this class called Pokemon. I apologize, I don't really know anything about Pokemon. I had a friend in elementary school who collected Pokemon cards, but I've never played any of them, so sorry. Sorry if I mispronounced something or like something stupid. I don't know. Anyways, so let's look at the kind of three parts of this function. So that's the variables, the constructors, and then the actual methods. So the variables we're using, notice we have two variables which are non-static, name and level, two variables which are static. I'll repeat this again because it takes a very long time for students to get this pretty often, is that a static variable does not belong to an instance of the class, it belongs to the class itself. So this Pokemon class is basically a template from which we are going to create a bunch of Pokemon objects. Those variables that are static belong to the template, not the actual instances, and those variables which are not static belong to the particular instances, right? You can also think of these static variables as kind of global variables in terms of instances of the class. So in other words, every Pokemon we create is going to have its own name, it's going to have its own level, which is separate from any other Pokemon, but they're all going to share a trainer and they're all going to share a party size variable, right? Okay. So now let's look at the constructor a little bit. The constructor probably does pretty much what you would expect it to do. It assigns the name to be name, it assigns the level to be level, right? So if we create a Pokemon with a name and a level like, Pikachu level 10 or whatever, it will create a Pokemon with Pikachu level 10. And then note it increments party size by 1. So this party size starts at 0. So just as in worksheet 1, if you remember, we had a variable called something, which basically started at 0 and incremented by 1 every time we used the constructor. Basically, it was keeping a global track of the number of bear objects we created. This is doing the same exact thing. It is keeping track globally of the number of Pokemon objects we created, right? And then this trainer is just going to be universal, meaning that every Pokemon shares the same trainer. Okay. That's that. We can take a quick look at some of the methods, but there's not too much to look at immediately. We see here, we have a main method. Normally we put the main method at the bottom of the class. Here it's in the middle. It doesn't matter. It's just here. And then we have two methods. The thing to notice here is that one of them is static and one of them is not static. So again, things that are static belong to the template. They belong to the class, not the particular object. So see here, notice here how when you call change, you pass in a Pokemon and you pass in a level, right? If it was a non-static method, you wouldn't pass in the Pokemon because the Pokemon is this, right? If you're calling a non-static method, you're calling it from the actual Pokemon, so there'd be no need to pass in a Pokemon because you're already in the Pokemon, if that makes sense. Here it is necessary because when we're static, we don't belong to any particular instance of a Pokemon, so we have to pass the Pokemon in itself. I know I've said the word Pokemon a lot, but it's kind of fun to say. And this hopefully will become more clear as we go through the actual process. Okay, so that all out of the way, that being all out of the way, let's look into the main method and let's start actually writing some things. So first thing I'm going to see is we're going to create two Pokemon objects here. Also, let me underline everything that's static just so I keep track of it. We're going to, you don't really do main, main's a little different. We're going to create two Pokemon here. So we're going to do the same thing we did before. We're going to have kind of a box and pointer diagram referring to all these different variables. So first thing I want to do is I want to have a class Pokemon. This is just going to keep track of the different static variables. So there are two static variables. The first one is trainer, which is just going to be Ash. And the second one is going to be party size. And the size of your party is currently 0, right? these are both static variables. That's why I'm keeping track of them in this class Pokemon. That's why I'm not putting a box around them, because it's not really an object. They belong to the class. Okay, once we do that, the first thing we're going to do is create a Pokemon P. Okay, so it means we're going to create a variable called P. It's pointing at something. It's pointing at an object, which we normally represent as a box. And what does the object have? The object has 4 variables. It has a name, a level, a trainer, and a party size. I'm only going to write 2 of them, and I will explain why in a second. Name and level. So it has a trainer and a party size variable, but remember, because it's static, it's referring to these things. In the last video, or in the last worksheet walkthrough, I basically would write the word trainer here, and I would write the word party size, and then I put a pointer up to the trainer and the party size, just keep track of it. I'm not going to do that here, just because it would clutter the diagram. This is a problem that gets really cluttered really quickly, and so I don't, trust me, you don't want to see me have a bunch of different Pokemon variables and see them all having arrows pointing up to these things. So try to keep in mind that when we refer to trainer, when we refer to party size, we are referring to these ones, right? If you yourself want to draw the arrow on paper, I encourage you to. I think it makes it easier to keep track of things. If I were taking exam, it is what I would do. I am not doing it for the sake of space and because I believe the official staff solutions generally don't draw the additional arrows. So anyways, the point is, whenever I create an object, I'm just going to keep track of the non-static variables in the object. Keep in mind the static variables are up here. They're easy to forget, so try not to forget them. Okay, so this is basically the framework. So now let's actually create the object, which means we're going to run the constructor. We're going to pass in the arguments Pikachu and 17. So Pikachu becomes the name, 17 becomes the level. These are both local variables. So the name just gets assigned to the name. That makes sense, right? Just say Pikachu. And then the level is going to be 17, right? So far, that hopefully makes sense. And then remember, party size is going to increment by 1. Don't forget this. So party size is initially 0. We're going to increment it by 1. And again, static variable, that's why it's out here. It's very easy to forget to do that. So I'd encourage you to explicitly, it's very easy to look at a constructor and say, it just assigns the name and the level. So I'll just, write that out here when you're doing this. Really do look at it line by line so you don't forget these important things like party size is now equal to 1. Okay, so that's the entirety of creating the first Pokemon variable. Great. Now we create another one, J, and we're going to do the same thing. We're going to create box representing the Pokemon. It's going to have a name. It's going to have a level. Remember, it's implicitly referring to these static variables as well. So if we run the constructor, we're going to assign the name to Jolteon. I do not know what a Jolteon is because I don't know anything about Pokemon. And this Jolteon has level 99. That sounds pretty high to me. Cool, I guess. And then, so we ran this line, and remember, remember not to forget to increment the party size from 1 to 2. And remember, party size basically keeps track of the global number of Pokemon we've created, and we've created 2 at this point, so it makes sense that there's 2. Also note that we have not touched the trainer yet, so Ash just stays the same. Great. So now we've created 2 Pokemon, which means we have 2 local variables here, right? P and J. These variables are local in relation to the main class, right? These variables don't exist outside of the main class, but the main class is kind of, as the name implies, it is the main class of the method. So it's where most of the kind of action happens, so to speak. Okay, anyways, so the next thing we're going to do is we're going to print out party size, and we're going to print Pokemon.party size. So we're accessing the party size variable directly from the Pokemon class, which makes sense because this is a static variable. So we're directly accessing it from the class. You could equally say p.party size if you wanted. You could say j.party size. It would be the same thing because remember, party size in P or J implicitly refers to this party size. So 3 ways to access the exact same thing, but we're just doing it one of those 3 ways. Okay, so what are we going to print? Well, we're going to print a party size like this. Party size has a lowercase s, so let's be correct. Party size and then 2, because that's what the party size variable currently is set to. Great, that's that line. This is where it starts to get a little bit weirder after that. Next is we're going to do p.printstats. Okay, so p refers to this p, right? This variable, this Pikachu object. And then printstats is a method down here. It is a non-static method, so it belongs to the actual p instance. So let's run it. But we see it's actually relatively simple. All it does is it prints the name, it prints level, and prints trainer. So because we are in a non-static method, we are in a method called from this Pikachu instance. It is implicitly this.name. This.name is, of course, Pikachu. This.level is going to be 17. And this.trainer, remember, is referring to the static variable trainer. So it's referring to Ash, right? It's referring to this kind of global variable. So we're going to end up printing Pikachu. How do I spell Pikachu? Did I misspell it? I may have, but basically it's Pikachu 17 because that's the level, and then Ash is the trainer, right? Okay, so now we're going to create a new variable called level. This is, I'm trying to find a good place to write it. I'll just write it here. This is a local variable, right? What is it local to? It is local to the main method. So this level variable, and this will become important in a second, is not accessible outside of the main method, right? It's a local variable. It only exists in that method. In the same way that, you know, well, I guess I don't actually have another example in this worksheet, but we'll keep explaining it. Anyways, so basically we're just creating a local variable called 18. Keep in mind though, because we're about to have a local variable, a bunch of local variables called level. Next thing we're going to do is Pokemon.change p and level. So change is a static method, right? So it makes sense to call Pokemon.change. It does not make sense to call p.change because p.change would be referring to a static variable from a non-static class. So you wouldn't do that. So we're going to call it directly from Pokemon. So Pokemon.change, what are we passing in? We are passing in p and we are passing in level. Okay, so let's look at this method. There are two variables here. There's Poka and there is a level variable. Poka is a pointer, level is just an int. So when we pass in p to Poka, what we do is we pass in the pointer basically of p. So this Poka here is just going to copy the pointer, and the pointer is pointing to this object. So this is another big thing. We're not passing p in literally, but we are passing in basically a reference to the object that p also points to into. So Poka is pointing at the same thing p is pointing at basically. And then level is going to be 18. So int is a primitive, right? And when you have a primitive, you just copy the value directly into the variable. So we copy this level variable, which is 18, into this level variable, which is 18. So here's the important thing. These are different variables. They have the same value, but they're different variables. If I change this one, it doesn't change this one, right? They're both local variables. This level is a local variable that is local to this method. This level is a local variable local to this method, right? This will become clearer as we continue with the method, but that's the big thing to kind of hammer home here. So let's actually start executing this change method. Great, we have Poka.level, so we have another level variable. This level variable is not a local variable, it is an instance variable. So if we go to Poka, we follow this pointer to this object, and we look for a level field inside that object, we find it. It is here. Okay, so to summarize again, there are three different level variables here. This one, a local variable of the main class, this one, a local variable of the change class, and this one, which is a instance variable of the Pikachu object. And if you really want to get pedantic, there's actually a fourth one, which is this instance variable of the J object, but we're not using that right now. Lots of different levels, basically. So keeping that in mind, let's see what we're doing. You're going to say Poka.level, which refers to this level, because we're pointing at this object, is going to be reassigned to be level. Which level? This level, right? Because when we just have the word level, it's the local variable. Remember how I said earlier that this level is not accessible outside of the main method, or we're not in the main method anymore. So we're not accessing it. Okay, all that is very nice and fancy and confusing, but basically all we're doing is we're changing the level of Pikachu from 17 to 18, right? And zooming out of the code a little bit, that makes sense because this is a method called change. We pass in a Pokemon and we pass in a level. It probably makes sense that we're updating the Pokemon's level. Okay, next thing is we're saying level equals 50. Which level again? It's this level because it is the local variable within the function we are currently in, is being set to 50. So now you can see that these things are different things. Notice that there's no pointers here. So this level is still 18. This one is now 50. Okay, and now we're going to create a new Pokemon. This Pokemon is going to be Voltorb, and it is going to have level 1. So let me rewrite the level variable up here to give me a little more room. So let's create a new Pokemon object. It's going to have a name. It's going to have a level. The name is going to be Voltorb. The level is going to be 1. And remember that every time we run the constructor, we have to increment the party size. So the party size is no longer 2, it is now 3. Don't forget to do that. Again, that's why you might want to draw these like pointers. I just didn't do that because we would have 6 arrows going up to this class right now. It'd be a mess. And the last thing we're doing is we are assigning this new object to the Poke variable. This is the Poke variable. Again, it is a local variable. It was created up here, right, in this particular function. So this pointer goes away, and it is now pointing here, right? So we've reassigned the Poke variable. This doesn't do anything to P, because remember, P is a variable that exists in the main class. We were accessing it before, but now we're just accessing a different thing, right? Okay, so we create this new Pokemon, and now we're going to say Poke.trainer is equal to Team Rocket. So Poke refers to this Pokemon object, and trainer is, of course, a static variable, which is this one up here. So we want to change this Ash to no longer be Ash, and now it is going to be Team Rocket. Oh no, it's Team Rocket now. Okay, and remember, this is equivalent to saying Pokemon, capital P, dot trainer equals Team Rocket. It's the same thing. We're accessing the same variable, just 3 different ways. We're either accessing it through a particular instance, we're accessing it through the class itself. Keep in mind that we cannot access it though via these instances because there's no P. P and J are local variables to the main class. There's no P, there's no J here. So if you try to say P dot something, it will give you an error. Anyways, okay, so that's basically everything. I know that method took a long time to get through, but we're done with it. So what happens when we're done with that method? It's actually garbage collection now, because these 3 variables we had, Poke, level, and well, it's actually just 2 variables, sorry. Poke, which refers to a new object we created, and level. These disappear after we are done with the method. So really what's going to happen is level is going to disappear, Poke is going to disappear, and then once Poke disappears, Java is going to realize, hey, you can't get to this Voltorb object anymore. There's no way to get to it because you destroyed the only reference to it. So this Voltorb object is going to disappear. Party size is going to remain 3 because, it's just a variable. It's not going to decrement for any reason, but the actual Pokemon we've created is going to disappear. Anyways, so we've finished executing this method. It took a little while. Now, if we do p.print stats, what are we going to get? So p, remember, we're back in the mainframe, still refers to this. So this Pikachu object. So it's just going to print Pikachu is going to print the level of P, which is now 18, right? And it's going to print the trainer. The trainer is now Team Rocket, right? Because we changed it up here. Great. Now we're going to say Pokemon.trainer. We're going to change it back to Ash. Oh no, there's a fight for supremacy here. So we change it for Team Rocket back to Ash. And then we change J.trainer to Brock. So J is this object, so we go into this object. We go to the trainer field of this object, which remember, because it's static, just refers to this trainer up here. So we're changing Ash to Brock. Remember, we're doing the same thing in multiple ways. If you said, Pokemon.trainer equals Ash, Pokemon.trainer equals Brock, you do the same thing. You said P.trainer equals Ash, P.trainer equals Brock, same thing, right? Just different ways to access the same variable. Okay, so we've done all that, and now we can print stats of P again. Well, so it's going to print its name again, which is still Pikachu. It's going to print its level again, which has not changed. It's still 18. It's going to print its trainer. Its trainer is now Brock. And as we all know, Brock saves the day in Pokemon, I guess. I don't really remember. Yes, whatever. Anyways, that's the entire problem, basically. This is what everything prints out. And this is kind of a diagram showing you what is going on. There's a couple kind of questions afterwards, which are conceptual ones. So it's asking on line 28, we set level to 50. What does that mean? I discussed this as we were doing the problem, but again, remember, there were a bunch of different levels here. There was level inside of the main method, which was a local variable, level inside of the change method, which was a local variable to the change method. There were the levels inside of the individual Pokemon. So they're all different things. That's basically what this question is asking. And then C is saying, if we were to call Pokemon.print stats at the end of our main method, what would happen? Give it a guess yourself. There's no need to write anything out. It's a bit of a trick question. But if we call Pokemon dot print stats or whatever it's called, or print stats. This is actually an error now. Why is it an error? Because Pokemon is the actual class, right? And if we're calling things from the actual class, they have to be static because you can't call something from a particular instance from the general class. It doesn't work. So remember when we were calling change, we were calling Pokemon dot, oops, where is it? We were calling Pokemon dot change because change is a static method, so we can call it directly from the Pokemon class. However, print stats is not a static method, so we can't call it from the local class or from the master class. And basically a way to think of this conceptually is, remember, when something is static, it belongs to the class. When something is not static, it belongs to the instance. So if you call Pokemon.print stats, it's trying to print the name, the level, the trainer. Does the class Pokemon have a name and a level? No, right? Individual instances of Pokemon have name and level, but the actual class does not have a name or a level. So it doesn't really make sense, right, to call print stats from the general Pokemon class because this is a method that's supposed to examine an individual Pokemon. That's the kind of conceptual reason why it doesn't work, but the literal reason is because you're trying to call a non-static method from a static context. You may have run into that error in IntelliJ where it says trying to call a non-static method from a static context. That's what it means. You're trying to do something which applies to a particular instance from something that is not a particular instance. That's all that means. So the point is, this would cause an error. Your code would not compile, and it would say like, oh, static context. Trying to call static method from a static context. Anyways, that is everything. I hope this series of videos has been helpful. Tune in next, not week, but in the next few days, and I will put out a series of videos for the third recurring worksheet. So goodbye.